Hey everyone, it's Miss Burgess. We are about halfway through our circles unit, and this week we're focusing on tangent lines. So you should have copied down the notes or printed them out and go ahead and follow along with my video. So, how do I use tangent lines to solve problems? You will be using tangent lines for the rest of your advanced math life. It's introduced in geometry, and it's a pretty simple concept. A tangent line intersects a circle at exactly one point, called the point of tangency. So here we have our tangent line AB on the left. So this is line AB. And notice that it intersects the circle at only one point. And a tangent line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. So we're going to fill in the notes. Perpendicular to a radius. So here we have our radius AP. And notice that our line intersects at point A in a 90-degree angle. So that is what makes it tangent. So if we have right angles, we can use properties of right triangles to solve problems. So let's go ahead and do number 1. So it says determine if AB is tangent to circle P. Okay, so we are going to test to see if AB is tangent by seeing if it is perpendicular. Okay, so we're just going to use Pythagorean's theorem. We'll do 8 squared plus 15 squared equals 17 squared. 8 squared is 64, 15 squared is 225, and 17 squared is 289. Okay, so we'll get out our calculator, and 64 plus 225 is 289. 289 is equal to 289. So yes, AB is tangent to circle P here. And you guys are going to do the same thing with number 2. Okay, let's do another one. So here we have number 3. I don't know what's happening, sorry. Okay, if line JK is tangent to circle L, find X. Okay, so line JK is tangent to circle L. We can go ahead and put our right angle in. And let's solve for the hypotenuse as our X. So we'll do 7 squared plus 19 squared equals X squared. Okay, 7 squared is 49. 19 squared is 361 equals X squared. 361 plus 49 is 410 equals X squared. And to find X, we'll just take the square root. 20.2. X is 20.2. Okay, so you guys are going to do number 4 on your own. And we will move on to number 5. So number 5, we are solving for X, which notice X is up here. So that is only a portion of our triangle. If we know that JL is 10, then from J to this part of the circle here is also 10. So we're just going to subtract 10 once we find our hypotenuse here. Okay, I don't know why my calculator keeps popping up. Sorry, guys. Okay, so we're going to do 10 squared plus 24 squared equals C squared. 10 squared is 100. 24 squared, times 24 is 576. Okay, that's a 7. Sorry, guys. So that's 676 equals C squared, and the square root of 676 is 26. So C equals 26, and that means our X is 26 minus 10, 16. Okay, so you're going to use number 5 to help you solve number 6 on your own, and let's do number 7 together. And I'll change the color again just because I like to. Okay, so here we have our circle with JK tangent to our radius, and we're solving for x. All right, so we're going to have to get creative here. We're going to call line LK x plus 10. That's our hypotenuse. So when we're filling in Pythagorean theorem, we're going to do x squared plus our other leg, 20 squared, equals x plus 10 squared. Okay. So x squared remains x squared. 20 squared is 400. And x plus 10 squared is x plus 10 times x plus 10. And we will FOIL. So x times x is x squared. X times 10 is 10x. 10 times x is 10x. And 10 times 10 is 100. So this reduces to x squared plus 20x plus 100. Okay, do you guys see the same thing on both sides? So this is my favorite thing to do in math. Same thing on both sides, cross it out. So we're left with 400 equals 20x plus 100. We'll subtract 100 to both sides, and we get 20x equals 300. And when we divide by 20, we get x equals 300 divided by 20, that's 15. Sorry, guys. Okay, so x equals 15. All right, good. That was a good challenge. Okay, so here's some more properties of tangent lines. If two segments from the same external point are tangent to a circle, then they're congruent. Okay, so line AB is tangent to circle D, and line CB is tangent to circle B. So because they're both tangent to point B, they are congruent segments. And they have to be, right? Because this radius is the same as this radius. Okay, if a polygon is circumscribed around a circle, then all sides are tangent. Okay, a polygon is circumscribed around a circle, so the circle's in the middle, then all sides are tangent. Okay, so this crosses at exactly one point, BC crosses at exactly one point, point E, and AC crosses at exactly one point, point F. Okay, so find each value or measure. Assume that all segments appear to be tangent are tangent. All right. So here we have two tangent lines. So we have tangent line AB and tangent line CB. Here's our right angles. Sorry for the bad drawing. And they are congruent triangles. So we're going to say 5x plus 23 is equal to 8x minus 19. Subtract 5x on both sides and we get 3x. Add 19 to both sides. 23 plus 19 is 42. Divide by 3. X is 14. All right. You are going to do the same thing with number 11. And let's find SV here. And number 12. So we set up number 12 exactly like number 10, where we set the two congruent legs equal to each other. So 10x minus 41 equals 4x plus 7. Subtract 4x to both sides, we get 6x. Add 41 to both sides, that's 48. And x is 8. Okay? So let's find the length of a leg. We could do 10 times 8. 10 times 8 is 80. 80 minus 41 is 39. So these are both 39. And our radius for both triangles is 17. So let's find the hypotenuse, SV. Okay, so we are just looking at one of these triangles. It doesn't actually matter which one. Here's our right angle. So we have two legs, and we're looking for the hypotenuse. 39 squared plus 17 squared equals SV squared, or C squared. 39 squared is 1,521. 17 squared is 289. So we'll add 289. 1,810 equals C squared, and take the square root. 42.5. Okay, so SV is 42.5. Okay, I'm going to leave you guys number 13 to do on your own, but let's do number 14 first. Okay, so we are going to find the perimeter of quadrilateral PQRS given this picture. Okay, so we know that if we have tangent lines that intersect at the same point, where is this one? There it is. Two segments from the same external point are tangent to a circle, then they're congruent. So here's our external point R. And here is tangent line QR and tangent line SR, which they're not the same length. But we do know that from the circle to point R is the same distance. So if this is 27.1, this is also 27.1. Okay? So I'm going to subtract 27.1 from 52.5 to find that other missing piece. So, 52.5 minus, where's my calculator going? 27.1 is 25.4. Okay, so here we have, from here to here is 25.4. And from here to here is 25.4. Okay, so now we can use that same property to find this piece, 23. This piece is 23. Okay, and we will find that tiny part from the middle of PQ to Q by subtracting, just like we did before. So 37.5 minus 23 is 14.5 and 14.5. Okay, so we can find the perimeter pretty easily now. We're just going to add. So we will do 14.5 plus 14.5 plus 23 plus 23 plus 25.4 plus 25.4 plus 27.1 plus 27.1. So Our perimeter is 180. Okay, that's a good perimeter. Alright, so you guys can use that to do number 13, which is slightly easier than number 14. Okay, if you have any questions, let me know, and don't forget to write your summary. Bye.